Dear students, we are on the CEC Gurukul lecture. We are in the series of electronic circuit, and in this series we are discussing the various electronic components which are used in the electronic circuit. In the today's topic we are discussing one of the important component, which is the transducers, which convert one form of the energy into the another form, which convert the one form of the energy into the another form of the signal, electrical signal. So these transducers are used in many components, in many sensing devices also. So we are defining the types of transducers further. So what are the, we define that type of transducer on the basis of its principle of operation. So define the photovoltaic transducers, which is a solar cell, piezoelectric transducers, chemical transducer, mutual induction, electromagnetic, Hall effect, and photoconductors. So one by one we define these type of the transducers. We discussed up to now the photovoltaic transducers, which convert the light energy into the electrical energy, and this type of transducers are the active transducer, because here we are not requiring any external power source. And this type of cells are made of the semiconductor materials, which is having the PN junction, and then when the light particles enter into the junction, that it energizes the junction and release the current into the conducting load, and this current is known as the photoelectric current. So it convert, here we are not required the any power electrical equipment, so that's why it is an active. We prepare the solar panel on the basis of that, and that convert the solar energy into the electrical energy, and that is the source of the green energy. Next transducers we define is the photoconductors. Photoconductors work in the similar manner as the photovoltaic, which use the intensity of the light. It depends upon the intensity of light, whose conductivity depends on the intensity of the light. More the intensity and more the output signal we will get through these transducers. In the another transducers we can discuss about the piezoelectric transducer, which based upon the pressure, force and the strain. So piezoelectric transducer works on the principle of piezoelectric effect, and which generates the electrical energy that is proportional to the pressure, force and the strain on it. So there are various materials which are used to prepare the piezoelectric devices. So one example is the quartz. Now it produces the changes on its surface when the force is applied on it, and this changes will produce the charges, and these charges can be utilized by connecting electrodes to its surface. A piezoelectric transducer is used for measuring the change in the pressure acceleration, and I have given the example, that is the automatic door, which sends the footstep pressure, and that open automatically. Moreover, the another example is the lighter, which generates the sparks to ignite the fuel. So these are the example of the piezoelectric transducers. So another type of transducers are the electromagnetic induction. That inductive transducers works on the principle of electromagnetic induction, which measure the changes in the inductance between the two coils. This can be done by either self-induction or mutual induction. A movable core is used between the coil of the transducer to vary the inductance between them. So physical quantities such as displacement, force, torque, acceleration can be measured by this electromagnetic induction. Next type of transducer is the Hall effect transducer. Such transducer works on the principle of the Hall effect, that can detect the magnetic field and convert that magnetic field into the electrical signal, which is proportional to the magnitude of the magnetic field. So Hall effect transducers are used for proximity and the position sensing, speed detection in the tachometer. So, Hall effect transducer use the magnetic field to convert into the electrical signal. And next is the thermoelectric transducers. As the name suggests that it uses the thermal energy. So, thermal energy converted into the electrical energy through this temperature transducers, that is a thermoelectric transducers. A thermocouple is a thermoelectric transducer. As we see in the laboratory that we use a thermocouple experiment, and that thermocouple work as a transducers which convert the heat energy, thermal energy into the electrical energy. A thermocouple is a thermoelectric transducer that has a two terminal, and one on the cold and one at the hot end. So, it produces the electric energy based on the temperature difference between its terminal. So, thermoelectric. Next is the electrostatic transducer. Electrostatic transducer is made of the two electrodes. So, two electrodes, how we use the two electrode? As it is the electrostatic. So, one electrode is fixed and another electrode is movable. And these are the movable charges with the opposite polarities. Both are having opposite polarities. So, when the movable electrodes moves, it changes the capacitance between the electrodes and vary the applied voltage. So, there is a change in the voltage. So, this change in the voltage is proportional to the electrode displacement. So, that electrode displacement will produce the electrical signal. So, electrostatic transducers are used there. Electrochemical, chemical where we convert the mechanical motion into an electrical signal. It can be used as sensing or measuring the mechanical displacement and positioning. So, electromechanical system. We can define the transducers on the basis of its quantity which we are measuring. So, so there are the different uses of the transducer. So, on the basis of that, the different type of transducer used for measuring the various physical quantities. So, various physical quantity like temperature, pressure. So, first we discuss the pressure transducer. That transducer that converts the pressure exerted into a electrical signal, and that is called the pressure transducer. It converts an elastic material, it uses the elastic material that bends when pressure is exerted on it. So, the bending is translated into an electrical signal that produced in the form of the strain and stress. The pressure transducers can use the following applications, where we can use we can measure the pressure inside a gas tank and detect any leak in case of the pressure drops. So, these type of transducers are used there. It is used for monitoring the flow of substance. Next, another important transducers are the temperature transducers. These temperature transducers convert the surrounding temperature into an electrical signal. It can measure the temperature as well as any change in the temperature. Like temperature we can measure as well as the change in the temperature. The thermocouple, thermistor are an example of the temperature transducer which are used to measure the temperature. And it is used for monitoring the temperature of the equipment also. We can control the temperature by using this thermistor or the thermocouple. It can also used to control and maintain the temperature inside the room or in any vehicle. So, next type of transducers are ultrasonic transducer, which convert the ultrasonic wave into the electrical signal. These ultrasonic waves are reflected from a surface that is detected by this transducers. So, ultrasonic waves reflected from the surface, maybe any from that can also use for measure the earthquake and another system. It can use detecting the object in front of it, and it can also use the measure the distance between the object and the transducers. And the speed of ultrasonic wave is equal to the speed of sound that is used in the calculation of the distance. So by using this ultrasonic transducer, we can measure the distance also. Next type of transducers are the displacement transducers, and these displacement transducers which convert the linear motion or the vibration into an electrical signal. Displacement, that name suggests that this displacement transducer convert the linear motion or the vibrations into the electrical signal, and it can sense change in the displacement and also measure the precise position of an object. And it uses the different principle of operation to measure the change in the displacement, such as the resistive, capacitive and the inductive etc. That type of displacement we can measure by using this inductive, and that is the one of the example is the linear variable differential transformer. Potentiometer is also used, and example of displacement transducer used for measuring the linear displacement. Next type of transducers are the flow transducers, which convert the flow of the gases, liquids into an electrical signal. It can use to measure the flow velocity in any gas or than a liquid. That also measure that it is also the amount of the flow of the liquid, amount of flow of the gases in any devices or in any circuit. So these are used. So next type of transducer are inductive transducers, which works on the principle of electromagnetic induction, as we already discussed, and it is the self inductance. It detects the self inductance changes, and it has coil that develops a magnetic field due to its own current flow. When an object such as a metal comes into its magnetic field, then its inductive varies, that is detected by the deflecting needle. So any change in any variation in the magnetic field can be measured by through this inductive transducers. It is used in the proximity sensors, metal detectors and object counters. Another type of that is important transducer, which is the strain gauge. That is strain gauge transducer converts a physical quantity like mechanical stress or the strain into the electrical signal, and it is made of the elastic material with trace of the conductors that does not break when the force is applied on it. So it works on the principle of change in the electrical conductivity or the resistivity of the conductor. When the force is applied, it bends and the conductor length and gets narrower, and that measures the so resistivity of the conductor changes. The change in the resistivity is translated into the electrical signal, and stress and when the stress is applied, the stress is also measured through this. The strain gauge transducers are mainly used for measuring the stress and the strain in the field of engineering. So acceleration transducers or the accelerometer is transducers that converts the acceleration of the body into the electrical signal. It can sense the change in the velocity and the change in the acceleration, and that can operate in the various principles like the acceleration transducer, which can notice the change in the velocity, and that can give in the form of the electrical signal. Next is the characteristics of the transducers. What are the characteristics of the transducers for which we are using? So we define the characteristics into the two types. First is the static characteristics and second is the dynamic characteristics, and which depends upon the overall performance of the transducers. So one is the static characteristics, second is the dynamic characteristics. Static characteristics are those which do not depend or vary with the variation in the input signal or with the time. Here are some of the static characteristics. First is the accuracy. Accuracy is the static characteristics which does not depend upon the variation in the input signal. So accuracy of the transducer is the maximum difference between its actual value and the indicated value. So it expressed in the percentage of the actual value. A transducer must have high accuracy to measure the physical quantity. Next is linearity. It is one type of the static characteristics. Ability of device to vary its output linearly with the input signal is called the linearity. The output in the proportional is the proportional with the input signal. What input signal we are giving, and we output in the form of the linearity, means on the basis of input the output we are producing. A transducer having the linearity has a more accurate reading when it can easily translate the signal to its corresponding output value. And next characteristic is the size. The transducer is having a small size, so it can be fit in any electronic components. Nowadays the electronic components are going to be miniaturized, so the size also depend. So we prepare the small size, which is crucial for installing component devices without taking much space. So next is the robust. A transducer must be able to withstand extreme environmental conditions and mechanical stress, and it work in a longer manner, and long lifetime should be there for any transducer. A rugged or robust transducer's perform is not affected by any environment. Repeatability, the ability of the transducers to generate an identical output signal multiple times when applied with the same input signal. So it work in this manner so that we can get the same output of the given input, the same input repeatedly. So the output signal must repeat itself and do not vary with time. Next characteristic is the stability. The capability of the transducer to provide the stable output and does not fluctuate. Sensitivity, that is the most important characteristics of the transducers. The ability of the devices to sense the smallest change in the physical quantity and translate into the efficiently into the another electrical signal, which is called the sensitivity. A device having the higher sensitivity can measure more accurately and precisely. We discuss the static characteristics. Now we discuss the dynamic characteristics. What are the dynamic characteristics? Dynamic characteristics of the transducers are dependent on the time and they may vary little. The input may if input vary, then the output we will get in the varying form. So here are the some of the dynamic characteristics of transducers. First is the dynamic range. First we define the range is the ratio between the highest amplitude and the lowest amplitude of the device that can efficiently convert. So that is having a high dynamic range has better performance and sensitivity. So we define a particular range in which we are getting the output. Next characteristics is the error. The error is a difference between the measured reading and the actual reading. The error can be caused by various factors. Speed. The speed plays an important role in performance of the transducer. So it shows how quickly it translates the physical quantity into the stable electrical signal. Another characteristics is the noise. Noise is a random unwanted signal and destroyed and inflicts the error in the original signal. A transducer adds noise in its signal. So low amplitude signal is more affected by the noise than a higher amplitude signal. So noise is one of the drawback in the transducers. Next is the hysteresis. So its ability to device whose output not only depend upon the current input but depend on the previous input as well. Efficiency of the transducers, which is the most important part. Efficiency of the transducer is a ratio of the output power to the input power. The percentage efficiency of the transducer never goes to the 100%, as some of the energy is wasted during the process of the conversion. For example, if we take the efficiency of the photovoltaic cell, which is below the 30%, so most of the energy is wasted in the form of the heat and reflection. So efficiency is one of the important point for development of the transducer. What are the advantages and disadvantages of the transducers? We will discuss some of the advantages and some of the disadvantages of the transducer. As we know the definition, that it converts the any form of the energy into another form. So we first of the advantages that we are getting the energy transform from one form to the another. So electrical signal of the transducers can be easily and quickly processed using the electrical circuit and the microprocessor. It works in a very less time. So it requires a less energy to control the electrical signal, thus more energy efficient. The electrical signal is easier to transmit and receive over the long distances. The electrical signal can be easily amplified, added, mixed, and other signals also be added in this electrical signal, which we are getting in the form of the output. The modern technology becoming smaller and more compact day by day, thus the electrical signal can be processed and stored using the very small gadgets and devices. So it plays a very important role. Transducers are made in smaller in size, but the efficiency is more. There are no mechanical parts involved in this, and it reduces the mechanical wear and the tear problem. Some of the disadvantages we will discuss, as we are having many advantages of this transducer, which are used in many sensing devices, many electrical component in daily life. We are using the transducers, but we are having some disadvantages as some transducers, especially the more accurate ones, are relatively very expensive in the preparation. Transducers are not reliable as compared to the mechanical instrument in the long term use. Sometimes they damage in a shorter time. Noise is an electrical signal that can affect the accuracy of the measurement. The output is not up to the mark as we given in the signal. The battery operated transducers performance is affected by the charge remaining in the battery. So the transducers are used to convert the one form of the energy into another form of the energy. So we discuss the sensor and we discuss the transducer. Sensors also convert the physical signal into the output signal, and similarly here transducer convert the one form of the energy into the electrical signal. So what are the difference between the sensors and the transducers? In terms of the sensors and transducer, which are used interchangeably in the electronic engineering, so is extensively used in the electronic application and other small gadgets and devices. So there are the many differences between the sensor and transducers. So sensors and transducers are used to convert the physical quantity and energy from its surrounding into an easily readable signal or the electrical signal. They are used to detect and measure the various physical quantities in the automation and the instrumentation. Still, there are the difference between the sensors and the transducers. You see on the screen that the left hand side we are having a transducer and on right hand side we are having a sensor. This is the one of the component. So what are the key difference between the sensor and transducers? A sensor is a device that detects a change in the physical environment. A transducer is a device that converts the one form of the energy into the another form. Sensor will detect and transducer will convert the one form of the energy into the another. A sensor is not necessarily a transducer, but every transducer includes a sensor as an component, because it made of the two components. First is the sensor and second is the sensing control unit. Another difference is the sensor itself is a component, but transducer is made of sensor and the signal controlling circuit. Sensor converts the physical quantities or the energy into the non-electrical signal, but the transducer converts the physical quantity or the energy into the electrical signal. That convert into the non-electrical signal, and this transducers convert it into the electrical signal. A sensors require an additional circuit to process its output signal into a readable form, but a transducers does not require any processing circuit. Its output is directly interfaced with a device or a display unit. A sensor's output is analog in nature, the transducer can generate the analog as well as the digital output. A sensor output cannot be directly applied to any other system. A transducer output can be directly applied, connected to the another system. A sensor does not require external power to operate, but a passive transducers require an external power source to operate. A sensor cannot bidirectional, that is, it only converts the physical quantity into the readable form, but transducers is bidirectional and it can also convert the electrical signal into the physical quantities called a inverse transducers. A sensor is a simple device, but transducer has a complicated electrical circuit and energy converter. If we take the example, that is the thermometer, pressure sensor, ultrasonic sensor and light sensor. If we take the example of the transducer, then we have the thermistors, potentiometer, piezoelectric transducers, Hall effect transducer, etc. So there is a sensor senses or detects physical quantity in its surrounding, while transducers convert one form of the energy into the another. Sensor is a component itself, while a transducer contains a sensor as a component in addition with the signal controlling unit. Thank you very much.